All right, so I'm going to do one. This is the last video probably on shifting of graphs. So you should be looking at this page on your notes. This page 275 is from your textbook. So if any of you are a little curious or want to see it written out a different way or see some examples, you can look at page 275. It talks about shifting. But I'm just summarizing your notes for you. So I know this looks like a lot of words, and a lot of you guys are going, I'm not going to read that, so that's fine. This is just vertical and horizontal shifts. So you've already been doing this in your homework. So if anything is next to the x, that is going to be in the opposite. So remember, we do opposite and same, right? So this is going to go, your x value is your horizontal axis, right? Your x-axis is the one that goes left and right. So this is going to tell me to go in the opposite movement. So I am going to go forward 2. So I'm going to go plus 2, and then I'm going to go up 4, so plus 4. This one doesn't have anything next to the x. You can think of it as plus 0 in here. Some people like to write that, so it's x plus 0 cubed. And that's fine if you want to do that. So there is no horizontal movement, and then it is going down 6. Remember, you want to take the opposite of 0, which is just 0. And then here, this is sort of like adding 0 on at the end. So this is going to go in the forward direction 1, and then it is not going to go up or down at all. Okay? So that stuff should be a quick summary for you. So now on the next page. So now this is the new stuff. So there is one more place, or two more ways actually, I can shift a graph. So we've already dealt with numbers either after the x, right next to it, or way outside. So there are two more places that I can add a number. I can either add a number here, or I can add a number here. So the good news is, the one here, we are not going to worry about. That is this section down here. So next year, you're going to do this in pre-calc. Okay? However, for those of you guys that are finding this chapter relatively easy, I am going to make a supplemental video for you guys, and I'll give you some extra challenge problems and probably give you some extra credit for it. So I will do one on this, but if you are finding this material at all challenging or right where, it's just hard enough, kind of like Papa Bear, Mama Bear kind of thing. If you're finding it just right or even a little challenging, then I don't want you challenging yourself to this, okay? Because it's just going to confuse you for the test. You're not going to be tested on this. You're not going to see any problems. I am going to cross them out in your homework. You're not going to get those homework problems from me. But we do need to worry about a number out here. So I'm going to call it A. So I can have, if I put it, and this is outside the parentheses, so it comes first. So that A can either be positive or negative. So let's just assume that that is positive right now. We'll talk about negatives next. So let's just assume it's positive. So that positive number can either be a whole number like 2, 3, 5, 7, 100, or it can be a fraction like 1/3, 1/5, 1/12, whatever. So I'm going to summarize this for you. So if you have a number that is bigger than 1, 2, 5, 7, whatever, it is going to make the graph either, you can think of it as making it more skinny or narrow. If it is a fraction, like 1/3, so here, why don't you do like example 2, 3, whatever. But if I have 1/2, 1/5, whatever, that is going to make it fat or wide. So I know those are not politically correct terms, so sorry. But anyway, so that's how it's going to shift it. So let's look at an example. If I look at this example here, I graphed 2 of them on my calculator for you guys already. So, and I am going to show you this on your calculator very, very soon. We're going to start working on these. So I put 0.2 on one, and this problem over here, I actually put in 0.2. So when I graph that, and then on another calculator, I put in positive 2. So I have 0.2 and I have positive 2. So when I go ahead and graph them, can you see the 0.2 made it very fat or very wide, and the positive 2 actually made the graph skinny? Okay? But this is really important, you guys. What I want you to notice is if you look at this over here, this critical point, hopefully you guys would have recognized as -2, -4, right? Notice that that -2, -4 is right there, and -2, -4 is right there. So it stayed the same. That critical point does not change. What's changing is how then, either how wide or how skinny I make my curve. But the starting point, the critical point, is going to be the same no matter what. So that number out front does not affect where I start my graph, it just affects how wide I make it. So for this class, it is perfectly fine. I'm going to do -2, -4, and I know this is a cube root graph and it's a positive cube root graph, so I know that basically it's going to look like this. If I have a number out front, so if I give you like 2, 5, 7, you just might want to draw it a little, a little wider, or actually 2 would make it very skinny, right? So it's just going to simply make it skinny on top of it. That is all that I need you to do. If you would like to be very precise in your drawing, and this is what I suggest down at the bottom of the page, what I suggest you do is you do a table of values. So start with your vertex, -2, -4, and then simply put another point on there. So I'm going to maybe pick -1. So -1, if I plugged it into my function up here, I would end up getting -2. So that would give me a second point. So that would give me the point, so I would know how, and then when I connect them and I go through them, it would just help me, it would help guide my graph, help me to know. I need to know, what that basic graph looks like, but it would just help me guide and know how fat or how skinny. And if you really want to be good, you could, you could pick another point. So I could maybe pick 0 in here. So I would get 0, 12. And that would just help me guide my graph a little bit better. Okay, so that is all I need you to worry about. Again, you will not see these in this class, so don't worry about those. So the summary of shifts on reflections. The only one that I want you to worry about is if it's negative. So hopefully you guys know, if I gave you a parabola, this is a positive parabola, right? So a negative parabola is simply going to be upside down. So that should be kind of easy, and this wouldn't matter if this were a absolute value graph. So if I had an absolute value, that's a positive absolute value, this is a negative absolute value. So what might be new is, so let me summarize these for you, and you might want to make a list of these. So what are our other graphs? We have the cube graph, so this is x cubed. Actually, so I'll do negative x cubed. So negative x cubed is simply going to reflect it like this. What it's doing is it's reflecting over the x-axis. So it's taking this and flipping it upside down, and it's taking this and flipping it up. Okay, so that is a reflection of the x cubed graph. Let me do, this is the square root graph. So the reflection over the x-axis would be down here. So this is the square root of negative x. Or the negative of square root of x. What else do we have to do? We have to do the cube root graph. So let's do the cube root looks like this. That's a positive cube root. So this is, and then I want the negative cube root. So that's a negative sign. And that is simply going to be, so this gets flipped over this way, and this gets flipped over that way. Because remember, you're flipping over the x-axis. So this would be a good time to stop the video and make a note of these, because you're not going to see these in your notes again. So make sure you know how to flip the negatives of them. I think the parabola and the absolute value ones, which were at top here, those, you can make a note of those as well, but make sure you know what a negative parabola and a negative absolute value look like. Okay? Okay, X-intercepts, Y-intercepts, we have been doing this all along, so I don't think I need to cover this. Just make sure you're substituting 0 in for X for the Y-intercept and 0 in for Y for the X-intercept. Okay, so now what I want to do is, for a couple minutes, I'm going to practice a couple of these, but then I want you, and I'm actually going to change a couple of them, and then I want you to practice a few more, and we'll post the answers, and I'll tell you where I'll post those in a minute. So let me do, actually I want to do a negative one. No, actually, I'm sorry, I want to do this one right here. So let's do, I'm going to skip the first one and we're going to do this one together because you're going to go back to that first one in a minute. So this guy, so I am going to, I just want, the first thing I always like to do is I'm reminding myself that that's what an absolute value graph looks like, but then I'm going to move my vertex. So my vertex is going to be 0, positive 3, right? So my new graph is going to be 0, positive 3. So that's my graph. Okay, I can get rid of this one now. So I just like to draw, actually I should have done it over here, sorry. So what is my domain of this graph? So my domain for all f, and I can just look at the graph. So you don't have to memorize. If you can memorize what the graphs look like, you do not need to focus on memorizing the rules. So know what the graph looks like, because I can look at this picture and I can see, hopefully you guys can see the domain goes from negative infinity to infinity. And hopefully you can see the range. Okay, so my lowermost y is positive 3, and it goes up to positive infinity. I want you to get really comfortable at drawing just a quick little sketch of a graph. Please don't do this stuff in your head. Don't memorize that absolute value graphs are domain negative infinity to infinity. That's ridiculous. Draw a little graph, draw a little picture, and then answer the questions. Okay, so X-intercept, Y-intercept. So this is y equals 0, x equals 0. So the easy one, x equal to 0. So when I plug 0 in here, so I get absolute value of 0 plus 3. Well, absolute value of 0 is 0, so this just equals 3. So again, and this is the difference between an honors level class and a regular level class. We are going to list these as points. This is in fact a point, right? That point, 0, 3, is on the graph. It's a point. So I want you to list it as a point. In a regular level class, the teachers probably would just take the answer 3. But I'm going to mark you off a point if you keep giving me numbers like that, all right? So, I'm sorry, I should have left more room up here. So I'm going to do the x-intercept down here. So for the x-intercept, remember I set y equal to 0, and this is another way of saying y. So 0 equals absolute value of x plus 3. So I'm going to subtract 3 over equals absolute value of x. Ooh, so is that possible? Can I ever have the absolute value of x equal negative 3? Does the absolute value of anything, can I ever, the absolute value says to take the negatives off. So can I ever get, when I take the absolute value of something, can I ever get a negative out? So no, that is not possible. So there is no x-intercept. But this is why I keep emphasizing draw a picture of the graph. Because I can see from the graph, oh, there is no x-intercept. This thing is never going to touch. So I didn't even have to, I could have saved myself, some test taking time, ACT time. This is critical. Draw yourself a little picture. You can usually answer a lot of the questions just from the picture if you know what your pictures look like. Okay? So this one up here, actually what I would like you to do is when you do this, I want you to change this to a negative. So I want you to add a negative right there. So please add this. Okay, you're going to change this, and then you are going to, when the video is over, you're going to solve this and then check on Schoology for the answers. I'll tell you where to get those. So I am going to do, I'm going to actually do this really hard one. So you're also going to do this one up here by yourself. It already is negative. And then I am going to do this one right now with you, and then you should be good to go. Okay? So I am going to, I'm going to draw my graph over here so I have more room over here. So my center, remember, I don't worry about this stuff first. So this is going to be positive 3, positive 1. So first step you should always be doing, positive 3, positive 1. I know this is a parabola, so hopefully you guys know that, but this is a negative parabola. So for now, I will be really happy if this is what you can draw right now. I will be thrilled. If you know that your center is at, or your vertex is at 3, 1, and you know it's upside down, and hopefully you recognize that actually maybe you might want to draw that, and then you might want to draw one like a little bit skinnier, That would actually be really nice if you did that. So that would show me that you know that this guy is a little skinnier, because it's a big number. Remember, the big numbers make it skinny, the fractions make it fat, kind of opposite of what you want to think. Okay, so let's answer whatever questions we can. Let's look down here and see whatever questions we can. So we can see that the domain is going to be negative infinity to infinity. All right, the x's keep going forever. My range is going to be negative infinity up to positive 1. Please don't write it as 1 to negative infinity, okay? I'll do this in black here. So I want you to see this does not go down. You don't start at 1. Remember, I always told you you have to start up. So you rise from the bottom, just like, when you get a job someday, you're going to rise to the top. So you start at the bottom and you work your way up. So we're going from negative infinity to positive 1. Okay? My x and y intercepts, so x equal to 0, y equal to 0. So let's do this one first. So if I set this guy equal to 0, 0 equals negative 4 minus 3 squared plus 1. Okay, So order of operation